At the renowned Solingen Industrial Museum, massive drop hammers thunder as they shape scissor blanks, a testament to over a century of German craftsmanship. This is where raw steel transforms into precision cutting tools through a fascinating blend of traditional skill and industrial innovation. The process begins with steel rods measuring 4 to 6 meters, 13 to 20 feet in length. A skilled splitter feeds these rods into a powerful splitting press that slices them into evenly sized pieces with precisely angled fronts. Each cut must be perfect. These will become the foundation of high-quality scissors. If you appreciate this level of craftsmanship, please subscribe and like this video so others can discover it too. Stay with us, you won't believe the precision of these drop-forged products. Before any scissors can be forged, specialized tools must be created. In the museum's tool-making shop, experienced craftsmen manufacture the dies that will shape split steel into scissor blanks. In technical terms, scissor parts are called the upper shank and lower shank. The toolmaker begins by heating a steel block in an oil-fired furnace to approximately 1200 degrees C, 2000 degrees F. Once glowing hot, the block is positioned beneath the hammer. 8 steps to perfection. The roughly formed die now undergoes 8 meticulous refinement steps. 1. Planing the impact surfaces. On a horizontal slotting machine, a short-stroke planer, the die's impact surfaces are planed to precise dimensions. The reference points come from carefully aligning the scissor eyes and joint. 2. Creating the slope. Through planing, the die block receives a deliberate slope, allowing excess material to flow sideways during forging, a critical detail that prevents defects. 3. Shaping by hand. At the vise, the toolmaker uses special riffling files to shape the exact scissor form, including fine details and the forging bevel. This hand finishing requires years of experience. For testing with lead. At the spindle press, the toolmaker tests the die's fit and dimensional accuracy using a lead model. A piece of lead is placed inside the clamped die and pressed into the shape of a scissor blank. This lead impression reveals whether the upper and lower dies align perfectly. 5. Precision measurement. The toolmaker takes precise measurements at the spindle press and transfers them directly onto the die through careful marking and scribing. 6. Final planing. Based on these measurements, the die is corrected on the planer and planed perfectly parallel. 7. Hardening. The die is heated in a hardening furnace to approximately 820 degrees C, 500 degrees F, then quenched in water to achieve maximum hardness. 8. Tempering. Finally, the dies are reheated to about 250 degrees C, 480 degrees F, and tempered. This crucial step relieves internal material stress, preventing the die from cracking under the hammer's impact. Finally, test forgings verify the exact positioning of the dies. At the vise, the toolmaker deburrs and inspects these test blanks. Only when the shape meets expectations can full production begin. Every scissor design requires its own dedicated set of dies. Developed in the 1880s, drop forging technology revolutionized cutlery production, replacing manual mechanical forging. It enabled manufacturers to produce raw goods efficiently in large quantities and countless designs, while still maintaining the quality that made Solingen famous. The smith heats the split pieces in an oil-fired furnace to approximately 100 degrees C, 2000 degrees F. The glowing steel passes between rotating wire brushes that remove surface scale before forging. The belt-driven drop hammer receives power through a line shaft, originally driven by a steam engine until 1956, later by a diesel engine, and since the 1980s by an electric motor. This connection to history is palpable in every strike of the hammer. After forging, the blanks cool slowly inside containers called tubs, allowing the steel's internal structure to stabilize. In another production room, a press operator demonstrates the deburring process. The first step is cutting away excess flash, the thin metal that's squeezed out between the dies during forging. At the eccentric press, the operator removes this outer burr in a process done entirely cold. For every individual step, a separate cutting tool must be mounted in the press. Punching out the scissor eye is also performed on the eccentric press. The leftover waste material is affectionately referred to by drop forge workers as whole mice. After deburring, scissor blanks are inspected, threaded onto wires, counted, bundled, and transported to the raw goods warehouse. From there, they leave the drop forge for further processing, either in traditional home-based workshops or modern industrial factories. Want to see even more incredible feats of craftsmanship? Check out our next video, and if you haven't already, please subscribe to our channel to support the preservation and sharing of these remarkable traditions.